right, number 47, Austin invested $750 in gold in 2010. Gold is gaining value at an average of 4% per year. Write an equation for the value of his gold after 2 years. So the value or the amount it's worth, the initial invested, and it's growing at an average rate of 4%, so 1 plus 0.04 to the t. Or you could say $750 times 1.04 to the t. When will his investment double in value? So right now he's invested $750, so the question is, when will that equal 1,500? And so, as far as solving, we're going to divide by 750. When you divide by 750, you get 2 equals 1.04 to the t. The inverse of the base 1.04 is log base 1.04. So log base 1.04, and you're left with t equals log base 1.04 of 2. Don't forget you can do the change of base, so just natural log of 1.04 divided by the natural log of 2. Or log, same difference, log 2, damn it, let's say that's wrong. Natural log of 2 divided by a natural log of 1.04. And so 17.673 years if you round. You can do the same thing with log 2 divided by log of the base, 1.04. Or you can do alpha log base, 1.04 of 2. And either way, you get 17.673 years after investment. That's how long it takes. All right. Number 48. The population of Harrisville can be modeled by the equation P of D equals blah. Does the equation model growth or decay? That is definitely a decay, because 0.93, which is the base, is less than 1. What is the rate of growth or decay? So remember, you can figure out the rate if you can rewrite it as 1 minus the rate. So 0.93 equals 1 minus r if if I subtract the 1, I get negative 0.07 equals negative r, and so r equals 0.07 or 7% decay. Notice how I did not say it was negative, because r is not negative, but you are decaying at 7%. Find the population of Harrisville in 2020 if it was founded in 1950. So the initial population evidently was 8,607, and then find the population in 2020. So that is 70 years later. So that means when t equals 70, so we're going to say the population at times 70 is 8,607 times 0.93 to the 70th power. So 8,607 times 0.93 raised to the 70th, and that is a very small amount of people, 53 people. Okay, becoming one of those ghost towns. So the only time I don't require decimal is when we're talking about live animate beings. Okay, so 53 people. When will the population be down to 1,000 people? So before 2020. 8,607 times 0.93 to the t will equal 1,000. First we divide by 8,607. So 0.93 to the t equals, I'm just going to leave it, 1,000 divided by 8,607. The inverse of an exponential base 0.93 is a log base 0.93. So I get t equals log base 0.93 of 1,000 divided by 8,607. Now, I could be solving these by finding the intersections by graphing, but it's so much easier if you just use your skills in solving. Log, well, just kidding. I'll do this one. Log base 0.93 of 1,000 divided by 8,607 and you get 29.662 years after 1950. So we're talking about 1979, 1980, somewhere in there. Okay, but that is the more accurate answer, and that's what I would say. Okay, using an exponential model without regression and the data in 2009 and 2012. So 2009 and 2012. Come up with an exponential model for PC. So PC, cool. Okay, so here's what I know. I know that the initial, like if time equals 0, then the initial sales in millions of the PCs is 33.5. So, let's see. That's going to be A naught, 33.5. And then I know that when time equals 1, 2, 3, when time equals 3, amount equals 36.6. So I'm going to use all of that to solve for K, and then once I know K, then I can write the model. So I know that the amount is 36.6 if I initially had 33.5 e to the K, and then after 3 years. So I'm going to solve that for K. I'm going to divide by 33.5 equals e to the 3K. I'm going to take the natural log, and then I'm going to divide by 3. So K equals can't see it on that side. K equals the natural log of 36.6 divided by 33.5 divided by 3. And that is 0.0295. I guess if we rounded it up to 3, it would be 0.03. You know what? I'm just going to go ahead and use that. Why not? It's easy to try one more. So amount equals initial amount 33.5 e to the 0.0295 t. So your model should have a as a variable and t as a variable, but then a naught and k should be values that you have like forever. So that if you wanted to find the amount of PCs at any time according to this model, you could just plug in the time, solve for the amount. Cool. Everything else needs to be plugged in. So that would be my answer. Or 0.03 if you rounded up. Okay. In part B, it says using regression, find a model for the sales of tablets from 2009 to 2012. Using this model, predict sales in 2013. Okay. So using regression. So I'm going to go to my stat, and I'm going to go to edit, and I'm going to put in 0.01. Nope, just kidding. I need years in there. So 0, 1, 2, 3. 0.01. I had to put it in something other than 0 because it won't do an exponential growth. Otherwise, 16.8, 62.7, and 113.5. I'm pretty sure this is very much exponential. We're going to go ahead and make sure. I'm going to clear out whatever's in there. I went to plot 1 and I went up and I made sure that was highlighted. I'm going to go to window. Time, I'm going to go -2 years, and I'm going to go 6 years just to see a little bit ahead. And then as far as y values, I'm going to go -20 just so I can see a little bit lower, and I'm going to go 150. And so I've got this one, this one, this one, this one. That definitely looks like a curve. So it says find a model, and we are going to go ahead and do exponential. So I'm going to go stat, calculate, exponential regression. It's list 1, list 2. I'm going to go ahead and store it just in case I need it. Alpha trace, Y1. And I'm going to go to mode because my stat diagnostics didn't show up. Not that it doesn't say I need it, but I'm going to go ahead and remind us how to get there. I'm going to go to mode and go up to stat diagnostics. Press on, second quit, second enter, enter, and I get this. So amount equals A, which is 0.072 times B, which is 18.7, if I round up, it's going to be 78 to the T. I'll go ahead and say that. Our R is 0.875 correlation coefficient, so that's an 87.5%. That's okay. It's not great. I wonder if linear would be better. Stat calculate linear regression. It's a lot better. I'm going to go ahead and stick with the exponential just because I was thinking exponential functions, but yeah, if I asked you to tell me which one's better, linear is much better. Okay, using the model predicts tablet sales in 2013. So if 2012 is T equals 3, then 2013 would be T equals 4. So amount in 2014, or when T equals 4, is going to be 0.072 times 18.78 to the 4. And I did store that in y equals. It's the more accurate version because there's no rounding involved. Remember to go over to the right so you can get, although it's numbers, well, it's in millions, so we can't do decimals. So 8987.308 million. Okay, if I just typed it in, 0.072 times 18.78 times raised to the 4th. Then we get 8956.016 million. And then this is calculator in the table. So I guess I'm going to take this answer, and then if you were to give that answer, then that would be correct as well. More accurate, in fact. Okay, part C. The function f of t equals 33.4 times 1.66 to the t models worldwide PC and tablet sales combined in millions 2 years after 2009. When does this model project 421 million PC and tablets are sold? Were sold. Okay, so the question is, this is millions of sales in millions 2 years after 2009, so whatever years we find, whatever answer we find, it's after 2009. So I'm going to say, when does 33.4 times 1.66 to the t equal 421? So we're going to divide by 33.4. And then we're going to take log base 1.66. So t equals log base 1.66 of 421 divided by 33.4. So out the window, log base 1.66 of 421 divided by 33.4. And I get t equals basically 5. So 5 years after 2009, which is 2014. Don't ask me why I read that way, because I don't know. Okay. Number 50. Using the exponential decay model, A equals A naught e to the KT, and the fact that the half-life of polonium-210 is 440 days. Find how long it will take the sample of polonium-210 to decay to 20% of its original amount. Okay. Okay. So I know that whatever the initial amount is, I'm going to have half of it after 140 days. So remember, our time unit is in days now. So if I want to solve for k so I can figure out the the decay rate, then I'm going to divide by A naught. So I get 1/2 equals e to the 140k. We're going to take the natural log of both sides. Wow, I just canceled out that thing. Okay. We take the natural log of 1/2. Those two simplify out, and I'm left with natural log of 1/2 equals 140k divided by 140. And I'm left with k equals natural log of 1/2 divided by 140. K equals -0.00495. I guess if I go by my rounding to 3, then I'll go that. Okay, so then the question is, how long will it take for it to decay to 20% of its original amount? So, you know, right here when I said A naught, you could have said 100 and then let this be 50. You could have let it be 10 and that be 5. You could have let this be 4 and this be 2. 80%. I could let the initial amount be 100 and then the final amount be 20%. Because I want 20% of the initial amount. But if I stay with this, the same theme over there, then it's 0.2. So it's 20% of the initial amount. E to the -0.005 t. And the question is, how much time does it take to get to that point? So we're going to divide by A naught. So 0.20 equals e to the -0.005 t. The inverse of that is natural log. So we're left with the natural log of 0.20, or just 0.2, equals -0.005 t. Divide. T equals natural log of 0.20 divided by -0.005. Natural log of 0.20 divided by -0.005, and that is 321.888 days. Don't forget that your unit is days. Now, you know, every time you use a rounded thing, it's not quite as accurate as it could have been. If we had used natural log of 0.2 and divided it by the actual amount, that right there, or that actual value k, then we would have gotten 325.07 days. So a little bit different. As long as I can see, you know, what you did. If you used 5 decimals, then as long as you wrote them out and I typed that in and got that, then that would be correct, okay? Okay. An island of 5,248 inhabitants are in trouble when one of their own contracts a virus, turning them into a zombie. Okay. So, when you're talking about a number of people on an island, then you're talking about no longer an exponential logistic, an exponential log. You're talking about a logistic because you have a carrying capacity. You only have 5,248 inhabitants, right? So, I'm going to remind you of some things. We've got amount equals carrying capacity over 1 plus A times e to the -bt. C is the carrying capacity. C over 1 plus A, because when time equals 0, that just goes away, is the initial amount, and then B is your part of your decay rate. So, or growth. What we're going to do is we're going to fill in what we know. I know the carrying capacity is 5,248 inhabitants. So, 5,248 inhabitants. I also know that when time equals 0, the amount of people, or the number of zombies, I should say, is 1. Yeah? So I'm going to set that equal to 1. And what this is going to do, when time equals 0, the amount of zombies is 1. This is going to allow me to solve for A, because B times 0 is still 0, and e to the 0 power is 1. So I'm actually just dealing with the equation. 1 equals 5,248 divided by 1 plus A. If you multiply by 1 plus A, then you subtract the 1, A equals 5,247. Cool? So I've got the amount of zombies equals 5,248 over 1 plus 5,247 e to the negative bt. So I still need b in order for this to be a fully fleshed out formula. So I'm going to use this other thing. When time equals 6, the amount of zombies is 153. So I've got 153 zombies. 5,248 over 1 plus 5,247 e to the negative b times 6. So my goal is to solve for b now. Okay, so I'm dividing by this, so I'm going to multiply by this on both sides. Now it's going to cancel out over here, so it's going to be 153. So, I'm going to erase this for myself. I'll write that back up here. Okay. So, I've got 153 times 1 plus 5247 e to the negative 6b equals 5248. So I'm going to kind of talk this out a little bit. The first thing I mean, you got a couple different options. You could distribute the 153, right? And then just start adding, subtracting, whatever, multiplying, dividing. Or you could divide the 153 out right now. It's kind of up to you. I'm going to go ahead and divide by 153. Although I like multiplying it out better, but I think most people would see this. So those go away. So I've got 1 plus 5247 e to the negative 6b equals whatever that is. I could type that in, but whatever. Next thing I'm going to do is I'm going to subtract the 1. Okay? And to save space, I'm going to go ahead and do the next step as well. I'm going to divide by 5,247. Cool? So I've got e to the negative 6b equals 5248 minus, divided by 153, minus 1, all divided by 5247. The next thing I'm going to do is I'm going to take the natural log of both sides. And then, last step, I'm going to divide by negative 6. So, b equals, ooh. Okay, mathematically this is not difficult, this is just a lot of work. So we divided by this, then we subtracted that, then we divided by this, then we took the natural log, then we divided by that. Cool? 5248. I work my way over. Divided by 153. I don't like typing these in because then I'm rounding, and then I'm rounding again, and then I'm rounding again while I write down the problem. So then I'm going to subtract 1. Then I'm going to divide that answer by 5,247. So then I'm going to take the natural log of that. So the natural log of that. And then I'm going to divide by negative 6. And that is what I get for B. B is 0.8433, or 0.843. I'll go ahead and write that. Now don't forget that in the formula it's negative B, so whatever you get for B, it's going to be negative. Okay, so come up with a model for the number of people, Z of t. So I actually should have said Z right here, but whatever. Okay, so for my answer for part A, I get Z of t equals 5,248 divided by 1 plus 5,247 e to the negative 0.843 t. And that is the formula for the population of zombies. E to the negative 0.843 t. Okay. All right. Part B. Use the model to predict the number of zombies after 12 days. So for part B, Z of 12 equals 5,248 divided by 1 plus 5,247 e to the negative 0.843 times 12. Cool. So 5,248 divided by Now, I'm going to put divided by, but if you don't put parentheses around the next part, then it's wrong. So it's easier if you just do alpha y equals and then do n over d. So 5248 divided by 1 plus 5247 times e to the negative 0.843 times 12. And we get 4,329 zombies. 4,329 zombies. It's kind of fast. But oh well. Part C. Use the model to determine how long it will be before only 1% of the population is not infected. So let's figure out what 1% of the population is, yeah? So 1% of 52,000 or 5,248 is 52 people. So if only 1% is not infected, that means 99% is infected. So let's go ahead and say 5248 minus 52. So 5248 minus 52. So, which means we have 5,196 zombies. Yeah. So 5,196 equals 5248 over 1 plus 5247e to the negative 0.843t, and we're trying to solve for t. So we are going to do kind of that whole rigmarole that we did up here again, which is kind of fun. But this time I'm going to distribute. So 5196, 1 plus 5247 e to the negative 0.843t equals 5248. I'm going to distribute this so you can see what it looks like that way. So 5196 plus 5196 times 5247 is 27263412. E to the negative 0.843t equals 5,248. Okay, so I multiplied both sides by this. That just went away on this side, and then I distribute my 5,196, and I got that. Cool. Now I'm going to solve. So I'm going to take this number, 5248. I'm going to subtract this number, so 5196. I'm going to divide by this number, 27263412. To get rid of an e, I'm going to take the natural log. And to undo the multiplication by that, I'm going to divide by negative 0.843. So, natural log of 5248 minus 5196, although we should know it's 52, right? Yeah, duh. Okay. Wait, what? Yeah, duh, it's right there. Okay. I don't know why I'm letting myself get caught up on that. Okay. Divided by. We're just going to go grab that number. Close my parentheses again and divided the whole thing by negative 0.843. And you get 15.623 days after the initial infection. Okay. So half a month later, and almost everyone is a zombie. That's too bad. Alright, I'm going to end that video right there.